Welcome back to another episode of Deep Dive Dialogues. I'm your host, Isabel, and today we have a very special conversation lined up, something that might just change how we think about testing AI math skills.
Nice to be here, Isabel. Always a pleasure when we get to dig into the nuts and bolts of evaluation.
Let's get straight into it, because honestly, the way we're currently checking if models can do math is kind of broken.
Channel everyone. So today we're talking about a paper titled Rethinking Math Reasoning Evaluation, a robust LLM-as-a-Judge framework beyond symbolic rigidity, which sounds intimidating, but I promise we'll break it down.
Right, so the core problem is simple. When we test a language model on a math problem, we usually just check if the final answer matches a ground truth, using symbolic math comparison, like checking if 2 plus 2 equals 4.
But here's the thing, models don't always output answers in the exact same format. One might say 4, another might say 4.0, or even write it as a fraction. Symbolic comparison fails on all these variations.
So you're saying the current evaluation methods are too rigid, like trying to fit a square peg into a round hole.
Exactly, and the paper proposes using an LLM itself as a judge, to evaluate whether the reasoning and final answer are correct, regardless of format.
They tested this against two popular frameworks, LightLevel and SimpleRL, and found clear failure cases where symbolic comparison just couldn't handle the diversity of answers.
So the LLM judge is more flexible. It can understand that 3.0 and 3 are the same thing, or that a fraction and a decimal represent the same value.
Precisely, and this leads to more accurate performance monitoring, which is crucial for advancing mathematical problem-solving in AI systems.
I think this is a step in the right direction, but we also need to be careful about bias. An LLM judge might favor certain styles of reasoning over others.
That's a really good point, Ji-young. But for now, this framework seems to offer a more robust alternative, and it's exciting to see evaluation methods evolving alongside the models themselves.
Absolutely, and the key takeaway is that we need to move beyond rigid symbolic checks toward more flexible, understanding-based evaluation.
Well, that's all the time we have for today. Thank you so much, JJ and Ji-young, for this fascinating discussion.
Thank you, Isabel. Always a pleasure.
Thanks for having me.
And thank you to all our viewers for tuning in. See you next time.